Hi, everybody. I just want to do a quick commentary on moving into working with vectors. Um, as I've worked with students and worked in 8.4, I've really been thinking about the fact that, boy, these really are all the same skills. I'm finding students are just like, oh, this is easier than I thought. And I think part of it is that, this introduction of vectors introduces a lot, like especially with symbols. Like if you start looking at something like this A with an arrow over it, and then these sort of sharp brackets that are coming into. Really, all this new symbol and new language is necessary because this triangle we see here is really, if you think about this force of A, any force can be broken into its horizontal push and its vertical push. Basically, that would be equivalent to working with Cartesian coordinates or XY coordinates. But really the transition is this A is not a distance, it's a force. So that kind of changes everything about the symbols, and heads up in working from 8.4 is being really clear of the kind of thing you're working with. Am I working with a distance? Is this measured in feet? Or is this like a force being pushed on something? So really that would be vector A broken into its horizontal and vertical components, as this is kind of that drawing refers to. And this next part is the same thing. Imagine these should look sort of familiar. You've seen these in the past, might look more like this, r cosine theta. It's the same thing. The added thing here is this absolute value looking thing around the vector A is really to define that that is its magnitude, or the strength of vector A. And the strength of vector A times the cosine of angle alpha, which in this case might be, say, that angle. And the magnitude of vector A times the sine of alpha. So one reason I added this part to just kind of be like, show something that might look a little different, is that wouldn't have to necessarily always be centered at the origin. You could put a vector anywhere. So for example, PQ, I added this illustration from one of the readings because it really doesn't matter where these are located. It's really about looking at what's happening between P and Q. So this could also be described as kind of the force of vector PQ is really made up of this horizontal force of 4 and this vertical force of 1. But together, they create, just like the Pythagorean theorem, 4 squared plus 1 squared. We could figure this out. The magnitude of PQ squared would be equal to 4 squared plus 1 squared. And this is exactly like using the Pythagorean theorem to understand distances. So that would be 17. And then we basically find out that the magnitude of PQ would be 17. And that magnitude is necessary because we're actually talking about a force as opposed to kind of the equivalent of an XY pair, which breaks that force into its horizontal and vertical forces. Anyway, there's just all these new symbols. Just really try to remember it's all the same math trigonometry skills that we've been using. It just works for forces as well. It doesn't have to be physical distances. I hope that helps you a little bit. It's been pretty quiet in these parts, so remember you can reach out for me for questions. My in-person students have certainly had a lot of questions, so don't hesitate to set something up. And have a good one.